Okay, this video is a short introduction to Ohm's law, or at least the properties of it. You'll be discovering the relationship when you do a gizmo. So you'll recognize the symbols in this circuit here, a 3-cell battery indicating electron flow from the negative terminal, right, through a closed switch to the load, right, and back to the positive terminal of the battery. So this electron flow, right, the rate of electrons flowing through passing a point in the circuit here, flowing through the wire, we know as current, all right? And the symbol for current is a capital I. All right, the unit, so what the units of current are amperes, which you might have heard as amps, right? And they're measured by an ammeter. We always place that ammeter in series, right? So it's placed in series in the circuit. So to use the symbolism then, we could say that I equals 0.9 amps. So I've just made up this number. I'm just showing you how we can use the symbol with an equal sign, state the number, and put the unit. So it's a capital A used to represent amperes here. So, or you could shorten it to say amps. All right, so I'll give you an example later where you can actually place the ammeter into the circuit. Now, voltage, on the other hand, right, voltage, or known as potential difference, is the energy change of an electron as it passes through the source, right, or across the load. So we know that the chemical reaction inside the battery, right, is where the electrons gain their energy from, and as those electrons leave, they possess a certain energy. When they hit this load, they're going to lose energy, and that energy is transformed into light and a little bit of heat energy with this light bulb. So we measure the voltage drop or potential difference, right, or the voltage of the electron. We measure it across the load here. So really looking then at the change of the energy change of the electron, right, as it passes through this load. When that electron has lost its energy here and returns to the battery, now it's going to experience a gain of energy. So we measure the voltage either across the energy source or across the load, because that's where the energy of the electron is changing. The unit is going to be volts, and we use a voltmeter to measure that. Remember to place the voltmeter in parallel, right? So in parallel across the source or the load. Again, just some symbolism here. So we use the capital V. So it's actually the same letter for the symbol and the unit here. So here we say voltage equals 9 volts. So if it was a 9-volt battery here, then we would say that V equals 9 volts. Now resistance is associated with the load. So how do we define resistance? Well, it's the ability of a material, so it could be a light bulb, a motor, to oppose a flow of electrons. The unit is ohms, that's how we pronounce this, ohms, and you'll see the symbol here to represent that unit as the omega symbol here. So R for resistance, right? The symbol for resistance equals 10 ohms. This being the unit, right? Ohms for resistance. We use an ohm meter to measure resistance, right? And it's placed in parallel across a load. So the load measures the load has the resistance. Okay, so now I'm asking you, I've got the same circuit that was drawn before, and I'm asking you to place an ammeter, a voltmeter, and an ohm meter to measure current, voltage, and resistance in this circuit. So first you have to decide, am I placing the ammeter in series, so somewhere along the wire, right? Or is it going outside, like in parallel with the load or the source? So hopefully you're thinking the ammeter goes in series. So we'll come and put that here. So maybe we want to measure the current here. So I'll maybe choose the green here. There. So the ammeter will measure the current, so it's going to measure the flow of the electrons, right, at this point in the circuit. All right, if I'm going to measure the potential difference across the load, for example, then I'll come over here and draw connecting wires there. And so here you can either draw the voltmeter across the load, or it could also be connected across the source. So I'll show what that would look like. Okay, so there's options there. Now the ohm meter, right, is used to measure the resistance, and so it needs to also be hooked up in parallel. So in the gizmo you're going to do, you'll actually remove the battery and put the ohm meter in its place, but I think I'll just show the ohm meter here. Okay, actually I don't want that to look like a light bulb, so just adjust that a little bit. Okay, so there's an ohm meter. So again, just with the idea of getting comfortable placing ammeters in series, voltmeters and ohm meters in parallel. Okay, there's a gizmo which I posted in the Google Classroom called Circuits, and there's actually a few pages to that accompanying Google Doc. I'm asking you to definitely do page 1 and 2. The rest of the pages that follow are so a good challenge and an extension there, but definitely go through the gizmo in that Google Doc and complete pages 1 and 2. There's a relationship you're going to discover as you go through that, and we'll pick up with some practice calculations and word problems in part 2 of Ohm's law. So that'll be in another lesson.